Hello, this is Vishwanathan. Uh, in this video, we are going to see how to build a predictive model and analysis using RapidMiner Studio. And in this video, I'm going to talk about three parts. First part is that analysis through various visualization, which is present in RapidMiner Studio, and about the how to build a predictive model using two methods: auto model and using process panel. First move on to analysis, and about this analysis, we are going to build a predictive model which will predict the heart attack based on dataset. And I'm choosing heart attack prediction dataset, which is downloaded from Cable, and the main feature of RapidMiner is that GUI, graphical user interface, where it can provide us a user interface where we can just drag and drop, and clicking some option we can visualize and doing some operation. There are two methods to build a predictive model. I already told auto model and using process panel. Another feature is the drag and drop. I already told, and we are going to see about various algorithm and operators, and RapidMiner features the GUI and auto model to predict the predictive model. These are all the features, and the main feature is turbo tab, where we can transform our data. It can even use to delete some attributes which doesn't contribute to our prediction. And about the dataset name is heart attack prediction dataset, and it has 8,763 records with 26 attributes. And steps to clean. At first, we clean the dataset, remove duplicates and value, and with outliers, and also the null values. Before going to about the cleaning the dataset, my dataset is have no missing values and duplicates and all those things which is cleaned already, and importing the dataset. If we work with RapidMiner Studio, we have to input data to our file location, and the attributes of the dataset are these. From these, some of them are not contribute to our prediction. And inbuilt function. There are some inbuilt function used for analysis. To view the inbuilt function used for analysis, we have to input our dataset to our local repository and drag and drop the data into the process panel and click run. Then in result tab, there will be option for data, statistics, visualization, and annotation. The individual operation, these individual operations used for analysis. First, we move on to data. Data is nothing but the dataset we can view. Just view the data, and statistics we use to view the in-depth details. That is the missing and statistic about the data, and most of the type of the data and the name of the attribute, all that, and also the visualization tab. We can use visualization. Now we are going to see how to build a predictive model to load the data, where we can have 6. Before that, we have to move on to auto model tab and load the data. And if we want to transform the data in using turbo pick, we can use that for removing attributes which cannot contribute to the heart attack risk, and we can even cleaning the data. After that, we can save the file in new tab by commit transformation, and we can use the load the data in first step, and we can use the data and select the task. We have there are three tasks: prediction, clustering, and outliers. We can predict and cluster and outlay those data. First I click predict, and we have to calculate the hot risk rate. So sorry, attack risk. So I click select the attribute, and move on to the next process, where prepare target. There will be something which will count the values in that attribute, and select inputs. Uh, 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 in this process, we have to select the attributes which will contribute. In auto model, it always suggests these attributes with green, yellow, and red. Green is accepted, yellow is in the middle, and red is about do not select those attributes. By the Rapid Miner Studio itself calculate the stability, correlation, missing, and textness and idness in percent, and based on the parameter, it will show us red, yellow, and green. After that, we select the input and go to the next process. We select the model type, where we can use the methods and algorithms. For regression, decision tree, random forest, and some of the algorithm models, and these algorithms are used to our predictive model, and select those model and click run. And the result page will contain the parameters for each algorithm. It will contain a demonstration part. Uh, from that analysis, we can tell, by analyzing these result part, we can choose the model which we give the low absolute error, and also the lowest time runtime. We can use decision tree for our model, and because it has less runtime, simulator is also used to predict. We see the demonstration, and in each model predict the hot risk in each model ranging from 0 to 1, and from the window of simulator, we can also analyze which attributes support the prediction and respect to the value given in the simulator. using process panel. Since every model takes the respective runtime, I will choose random forest and decision tree. Here I use some operators, and for that, by using these operators we can build a predictive model in process panel. uh, First, description of the operators. Multiple creates a copy of rapid minor object. If you want the output of one model to be the input of other two operations, or some operation, or some conversion, we can use multiply and set role. We can use to set the target attribute which we should predict, and apply model. This will use for applying our model based on the method or algorithm. And performance, it will calculate the performance like root mean square error and absolute error, these and all. And decision tree, it generates decision tree model and random forest model. And these operators we will use for our prediction. And here we retrieve the hot prediction data set, and we multiple. I am going to predict using two models in the same process panel. So I set the role, and using decision tree. And why this multiple? Because it goes for performance, also for output, where I can also give something which is relevant to the simulator. And here I am going to only performance, because it needs a nominal attributes to calculate random forest. So I am going with performance. And the performance is used here is for regression, because in random forest it needs nominal. So I am going to use performance is regression. And we move on to the demonstration.